Hello, in this short video, I will be discussing the evolution of Wi-Fi standards and why these new standards were added. 802.11x terminology was originated by the IEEE, which sets the standards, while Wi-Fi X terminology is originated by the Wi-Fi Alliance, which runs industry interoperability tests. Here, I will show the mapping between the equivalent terms. Beginning with the first standard, IEEE 802.11 was released in 1997, followed by 802.11b and A in 1999. 802.11g came out in 2003, Wi-Fi 4 was later released in 2009, and Wi-Fi 5 in 2013. The newest developments include Wi-Fi 6 and Wi-Fi 6E, released in 2019 and 2020 respectively. With Wi-Fi having been in the market for over 20 years, there have been numerous enhancements over time. The first standard, IEEE 802.11, was created to operate in the 2.4 GHz frequency band with a singular channel size and a maximum data rate of 2 megabits per second. The 2.4 GHz band is shared by many other wireless standards, and the modulation used limited data rates, causing low throughput. With each standard released after, the physical layer standards were enhanced to improve speed, throughput, and efficiency. Previous standards used SISO, or single input, single output, which posed issues with bandwidth, interference, and throughput. Wi-Fi 4's release focused on increasing throughput with its biggest enhancement, MIMO, or multiple input, multiple output, which allows users to receive and transmit simultaneously through multiple antennas. A 40 MHz channel was also added, which provided an increase in data rate availability over a singular 20 MHz channel. Wi-Fi 4 included a power save mode that was on a fixed schedule to reduce energy consumption. Recently, IoT has become an extremely important technology as people begin to use more and more devices as everyday objects. With Wi-Fi 4, it became possible to connect all these devices to the internet, enabling faster and more efficient communication across the globe. Furthermore, the release of Wi-Fi 4 was a milestone for IoT use. Wi-Fi 5 was built for performance and aimed at solving the network congestion issue on the 2.4 GHz band by using a less congested frequency channel, the 5 GHz band. Wi-Fi 5 introduced mu-MIMO to increase throughput speeds even more. mu-MIMO, or multi-use multiple input, multiple output, allows multiple users to access a wireless network simultaneously without interruption. It also uses 80 MHz channels, quadrupling throughput and increasing the maximum data rate to almost 7 gigabits per second. However, Wi-Fi 5 was not designed for the industrial use and is mainly used in smartphones, laptops, tablets, etc., as the 5 GHz band doesn't allow signals to travel far distances. While all previous standards prioritized increasing throughput speeds, Wi-Fi 6 places more emphasis on increasing efficiency and decreasing congestion in high-density environments. The Wi-Fi 6 standard introduces OFDMA, which allows for multiple user access by subdividing a channel, like subdividing a single road into multiple lanes for use by different cars at the same time. It also implements bidirectional mu-MIMO compared to only downlink mu-MIMO offered in Wi-Fi 5. BSS coloring is used to color code shared frequencies, which allows access points to determine if simultaneous use of the spectrum is possible, thus increasing network efficiency and data transmission in highly dense environments. Wi-Fi 6 introduced target wake time, a power-saving mechanism that is more efficient than Wi-Fi 4's standard, as it can detect user activity to determine when to sleep and wake. Overall, the latest Wi-Fi 6 standard brings greater scalability, reduced interference, faster performance, and lower latency, leading Wi-Fi 6 to be the next dominant enterprise Wi-Fi standard. An extension of Wi-Fi 6, Wi-Fi 6E introduces the new 6 GHz frequency band, a band never used before in Wi-Fi, providing essentially no interference with other devices. Wi-Fi 6E was also designed with the goal of making the 160 MHz channel more commonplace. Wi-Fi 6E uses the full bandwidth and spectrum of 6 GHz, aimed to improve applications like 4K and 8K streaming, VR gaming, AR technology, and can be a benefit in IoT as well. In review, the release of Wi-Fi 4 showed a large advance in Wi-Fi capabilities, which Wi-Fi 5 and Wi-Fi 6 both built upon. Wi-Fi 4 introduced a dual band, another channel size, significantly higher speeds, and MIMO. Wi-Fi 5 introduced even more channel sizes, higher speeds, and mu-MIMO. Wi-Fi 6 focuses on high efficiency in dense environments using more channel sizes for faster data rates. Wi-Fi 6 also introduced OFDMA as well as other performance-enhancing mechanisms. Wi-Fi 6E introduces the new 6 GHz band to reduce congestion. With the release of each of the newer Wi-Fi standards came an increase in the number of possible simultaneous spatial streams, allowing for the exponential increase in Wi-Fi users. Wi-Fi standards have evolved greatly over the past 20 years, resulting in faster speeds and network efficiency for users around the world. There are many factors to consider when choosing a Wi-Fi standard, and we hope that you can now effectively choose the right one for your system. If not, TI engineers are here to help you choose. For more information, please visit ti.com/Wi-Fi.